evening once again. So, my topic for this session is transparent machine vision techniques for voice sorting. So, I'm going to go deep into what I was supposed to do today. So, today we are basically going through a research paper. The research paper is waste classification for sustainable development using machine recognition, deep learning neural network model. So, if you look at the keywords in this paper, we have data classification, we have convolution, neural networks, machine learning, B0. And then our link to a paper is underneath that. So, we go to our computational problem. So, our computational problem, we have developing an image recognition system using deep learning neural network models to classify different types of waste for efficient disposal. The system should be able to categorize waste items such as can, bottles, disposable glasses, cheap packets, food, chairs, sofas, computers, tires, and refrigerators into hazardous and non-hazardous, as well as disposable and non-disposable categories. The goal is to assist waste management organizations and individuals in proper handling waste to achieve ecological balanced and sustainable development. So machine learning models used. We have one groundbreaking technique for solid waste classification is the use of CNNs in deep learning. CNNs are deep learning models widely used for image recognition, allowing images to be annotated with appropriate labels. While deep learning is still a subject of research, it has transitioned from research labs to commercial applications into various fields. A framework of image processing techniques is applied to the existing dataset for data classification within images and subsequent data categories. So we see the field of image classification has witnessed some of the most advanced AI research in recent years. The most efficient models for image classification have been introduced as efficient nets. These models are efficient implementations of CNNs with varying number of input layers ranging from 237 efficient B0 to 813 efficient net B0. So if you look at this graph, we see as the name suggests, is highly efficient implementation of CNN. So we have the number of input layers from B0 to B0 813 B7. Okay, so efficient net are the CNN models processed by computer researchers, Tan and B in May 2019 in the benchmark paper. So efficient rethinking model scaling for CNNs. The motivation behind the use of efficient net proposed data classification is that it exhibits a remarkable high accuracy of 84.3% over ImageNet while having 8.4 times smaller memory requirements and being 6.9 times faster than the best existing CNNs for image classification. So this is after doing intensive research from the other papers. So we have proper framework for classification using efficient net B0. So the model efficient net B0 is a pre-trained model using ImageNet with 1,000 classes of objects. The model is used as a baseline model for solid waste classification. The internal layers of B0 models are frozen to avoid any loss of information contained in them. The model is used with ultimate layers output. The output serves as an input to CNN in a pipeline manner, which is further trained over the secondary dataset. Secondary dataset refers to a specific data set of a solid waste image, which is specific to the particular region under consideration. For example, in coastal areas, the solid waste comprising of coconut shells is common, whereas in dry regions, potable water bottles and cold drinks cans are most common. So the score data set of images and class is used to train a set of layers only. These layers would learn to map and map the old features into predictions over the new data set, thus implementing transfer learning over the CNN model through pre-trained efficient data. For the limitations of our model, we have complexity and computation. Despite being efficient, the native versions of the efficient net models, such as P7, can be expensive to train and deploy, especially resource trained devices. We have generalization. While efficient nets perform well on benchmark datasets like ImageNet, their performance may not generalize well to real-time scenarios or datasets with different characteristics. This is because the models are trained on specific datasets and may not learn features that are relevant to diverse datasets. As a result, their performance may suffer when applied to new and unseen data distributions. Interpretability is another limitation of this model. So we have efficient models. Like many deep learning models are often considered black boxes, meaning it is difficult to understand how they make decisions. This lack of interpretability can be a significant limitation, especially in future applications such as understanding the reasoning behind a model's decision is crucial for trust and accountability. We have data efficiency. While efficient nets are designed to achieve high accuracy with fewer parameters compared to traditional models, they still require large amounts of labeled data for training. This can be a limitation in domains where labeled data is scarce or expensive to obtain. Additionally, collecting and automating large data sets can be time consuming and labor intensive. So, in conclusion to our model, we see in this work we have used the transfer learning techniques over a base model, B0, improvising its calculation accuracy for solid waste images and making it easy in a particular domain. With the B0 model, thus achieving an 85% image classification accuracy, with a model of which the upper limit of accuracy was previously 80%. However, this is for a specific group of images that corresponds to litter. For the future scope of the work, the proposed model can be extended to the identification of subclasses among the same class. As indicated in the popular waste images dataset consisting of 34 classes, the same will be extended into subclasses. For example, the class carton can be extended into large, medium, small, wood, cardboard, plastic, or any other related class. Moreover, transfer learning can be implemented using efficient net B0 to B7, which gives state of accuracy over the image net dataset. Moreover, there is a number of issues that need consideration when implementing the model. For example, as part of a smart city project, these issues include the development of autonomous vehicles mounted into robot arms and an HD camera, and efficient operation cycles over various types of areas with solid waste content. So we have our references, which we have outlined below. These bullets show the numbers of references: 1, 2, 3, 4, 5, 6, 7. So with that, I think I'll end today's class. Thank you so much for listening. Next time.